IUPAC nomenclature of an organic compound. So what is the IUPAC nomenclature of an organic compound and why do we use this nomenclature? The thing is that we have multiple names of the same compound. Like some names are scientific name and some names are common names. Let's suppose sulfuric acid, that is going to be H2SO4. Like sulfuric acid is H2SO4, and sulfuric acid is also known as oil of vitriol. Sulfuric acid is also known as oil of vitriol. In the same way, we have copper sulfate. Copper sulfate is also known as blue vitriol. A lot of things like this we have. Let's suppose methane. Methane is a scientific name, is also known as sui gas, is also known as marsh gas. So for the same compound, we have multiple names. Some names are local names, like sui gas is a local name. So in Pakistan, there is a place which is called Sui. So the gas is discovered at that point. So this is known as Sui gas. But let's suppose if I go somewhere for some research work and let's say I had sulfuric acid and it's finished. Now I went to any chemist shop and I said that I need oil of vitriol. I'm not saying sulfuric acid. I'm saying the common name, like the local name. So might be possible he would not be able to understand what I'm asking, what I need. So there would be some sort of communication gap. I can't make him understand and he would not be able to give me something else. So the thing is that uh, what can I do for this one? So this is the situation when the scientists have felt at that time, I think so it 1980s or something else. So they have finalized some sort of rules. According to that rule, we have to name the compound and the name of the compound should be globally same. Like if in Pakistan it is going to be methanol, so everywhere it should be methanol, like throughout. But we have to know some rules by which we are going to give the names to an organic compound. So what are the rules first? So this classification of naming is known as IUPAC nomenclature. IUPAC naming nomenclature. IUPAC naming. So
Okay.
IUPAC naming means that it's a basically International Union Pure and Applied Chemistry. International Union Pure and Applied Chemistry. So we set some rules. On the basis of that rule, we can identify the name of the compound. So rule number one. Rule number one says select. Rule number one says select longest continuous. Select longest continuous carbon chain. Select longest continuous carbon chain. Then identify the branch if there is any and give the least number and give the least number to it. Then rule number three, give the least number to it, and then we have rule number 3, which is uh, which is going to be um, put comma between number and number and hyphen between number and alphabet, between number and alphabet. Or when we are going to give the name, so we have to first define the position of branch, then the name of branch, and then the name of the long chain. So I can say number one, position of the branch, then the name of branch, and then name of long chain. Name of long chain. Or use die for 2, try for 3, and tetra for 4. Or one thing that is very important, that the branch can never be on the extreme corners. On the extreme corners. So starting from number one, alkane, starting from alkane, number one is C, then C, then C, then C, then C, then C. CH3, then CH3, then CH2, then CH2, then CH2, then CH2. So number one thing, I'm going to select the longest continuous carbon chain. So how many carbon atoms in this chain? So I would say 6 carbon atoms in this chain. So it's going to be N hexane. It's going to be N hexane, right? It's going to be N hexane, or N means normal chain.
Right.
N means the normal chain, like there is no branch. The normal chain. So what do you mean by like select the longest continuous carbon chain? So we mean to say that it's going to be uh, like longest continuous carbon chain. Uh, like I mean to say if I would be writing this structure in this way, I'm going to make the valency that should be fulfilled for each and every carbon like that. So you can see this again, it's a continuous chain. If again this is, I'm going to share my screen. If again this is a continuous carbon chain, so what I can do for this, I would be writing that this is again going to be an hexane. It's a normal hexane. There is no branch in this. I feel that this should be a branch, but on the extreme corners, on the ending of any of the organic compound, there should not be any of the branch present. So means that it's also a part of long chain, by the way. Or what if I am going to like draw this structure in this manner?
By the way, in the second one, yeah, that's also a hexane, like both of them. Like,
Yeah,
why
this
have
is
you
also
drawn them
hexane
like
because six
down?
carbon
Like,
atoms.
no, no, like, why is the line down? Why isn't it like in a
Basically,
straight
I
line, like
want to give you
one
the
above?
concept that branch, yeah, branch is something else. There is a difference between the branch and the straight chain. So it's a continuous chain. So I would consider that there is no difference between this and this. Just I have twisted this compound. So nothing is
Oh,
changed,
okay.
by the way. So
So I'll
what
write them
if,
like both ways, right? Both are
yeah,
correct.
exactly. Both are correct. Because sometime he would be giving you this compound and you will assume that this is going to be the new compound because we have to discuss isomerism afterwards. So most of the students think that this is another isomer of the same compound. Why? Because the structure is different. No, structure is not different. It's the same. Because in that case, when I would be writing any of the branch, that I can say like the structure is different. But right now the structure is the same.
Okay.
So let's suppose I have this one. So again, I would say this is going to be n hexane, the same thing. There is no difference because it's again this is the uh, straight chain compound because at the endings, extreme corners, there should not be any CH3 present. It's also a part of long chain. So I would say this is going to be an hexane simple. Or what if I would be writing in this way like that, like this. So continuous carbon chain. So again, I would say it's going to be an hexane. Again, I can say it's going to be an hexane. In the same way, like that, this one. So if you can select the chain, so I can say it's going to be an hexane. So basically, that's the concept of the branching. Like where should the branch is uh, what is the branch and how do I represent the branch? What should be the position of the branch? So the position should be so the position should be uh, on the second carbon atom or on the third carbon atom. Okay. Or let's suppose if I have this structure, one, two, three, four, five, and six, like that. So this is the long chain. This is going to be the branch. This is going to be the branch. That's the concept of the branch. That's the concept of the branch. So the branch should be in the middle. And of course, the mid position starts from the second carbon, not at the first carbon atom. Because at the first carbon, the branch can never be present. So starting from the second carbon atom, and also the branch can be at the third position. Okay. Or so I can say now what I have to do. Select the longest carbon chain. I have selected it. Then I have to identify the branch. If there is any branch, if there is any branch, so just select it or just number it. It should have the least number. It should have the least number. So I can say 1, 2, 3, 4, 5. Or
There's
if I
also
can,
one more carbon, right? It's
yeah, if I can count from the left hand side, it should be 1, 2, 3, 4, 5. If I am counting from the right hand side, if I am counting from the right hand side, so this branch is having the second number. Like the branch is present on the second position. If I'm counting from the left hand side, so the branch is present on the fourth position. According to the given
right.
rules, the branch should have the least number. According to the rule of the IUPAC nomenclature, the branch should be at the lowest position, at the smallest number. So what can I say for that? 2, like the position of the branch, as I told you, first of all, position of the branch, then name of the branch, then name of the longest continuous carbon chain. So I did 2. Then what is the name of this branch? What is the name of this branch? This is CH3. This is what? This is CH3.
Hmm.
So
Yeah.
like CH4 was methane.
Hmm.
CH4 was methane. So the CH3 would be methyl. Is
Right.
less from the initial compound. So the name is going to be from N to il. Like in short, it can be converted. It can be converted from alkane to alkyl. Like one hydrogen is decreased from the original compound. So this is called alkyl group. So in
Right.
alkyl group, there is one less hydrogen atom. And
What's
if I
the
have,
general formula for the alkyl?
what's the general formula for alkyl or alkane?
Yeah, yeah, like for alkanes, it's CN plus H plus something, right? C.
CnH2n plus 2.
Yeah, that's for
CnH2n
alkane
plus 2. That's for alkane. And for alkyl, CnH2n plus 1.
plus one.
Yeah,
Okay. All right.
because I have subtracted one hydrogen from the original compound. So it becomes,
Okay.
so for this CH3, I can say, for this CH3, I can say it's methyl. It has one carbon atom. So it's methyl. So two, then the name of the branch, it's methyl and hexane. No, sorry, pentane. Pentane.
Um, what is CH2?
CH2 is nothing. Basically, CH2
Oh,
has two hydrogen atoms, which I have just put to balance the valencies.
right, right. Okay.
Yes. Or so this is called 2 methyl and then pentane. So that's the branch. That's the branch basically. Or let's say 1, 2, 3, 4, 5, and then 6, like that. If I select the longest one, so it's going to be the branch. When it's going to be the branch, so I have to number it. According to the rule, the branch should get the least number. But interestingly, if I'm counting this from the left hand side, it would be getting 3. If I'm counting it from the right hand side, so it's getting 3. So the same thing, it's up to you from where you are supposed to count it. 1, 2, 3, 4, 5. I can say 3-methyl pentane. 3-methyl pentane. And what if uh, I'm giving you, let's suppose, C, 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 and then C, and then C.
Yeah.
What do you think? What should be the name of this compound?
There is one, two, three, four, five, six. So that would be hexane, hex something. Then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogen. So that would be hexane something. And it's on the second carbon. So two hexane something. Not
Two
hexane.
hexane.
No, no, not hexane. Not hexane. Um, there's a CH3 and there's a CH2.
Yeah.
CH2 mean that it is. I'm not sure about this one. Don't
So
know.
first of all, we have to select the longest continuous carbon chain.
Yeah,
So
that's the
the thing
first one.
is, so you are saying this one.
Hmm.
How many carbon atoms are present in this longest continuous
Four,
carbon
four.
chain? Four. Four. Okay. Uh, what if, what if I am going to make a long chain like that? What if I am going to make a long chain like that?
Okay, it makes sense now. Wait, 1 second. Now I can say this could be uh three methyl uh pentane as well. Is it the same thing?
Yeah, exactly. So the same thing.
Yeah.
So I would say that this is going to be the branch. Now I have to number it
Hmm.
1, 2, 3, 4, and then 5. 1, 2, 3, 4, and then 5. Now the branch is present at the third position. So it's gonna be
Right.
3-methyl and pentane.
Right.
3-methyl and pentane. So that's the name, that's the IUPAC name. So you can see the design is different, but
Yeah.
technically this is the same. Technically this is the same,
Okay.
so I can relate it. So we have to see after looking at the structure that what the structure is. So we have to just name it because in isomerism we have to draw different structures, of course different designs. So in the case, if you are thinking that like I have made a different structure because it looks like that it's all like they are all different, but when you but when you name it, then you found that oh the name is same. So if the name is same, you can't say that you have drawn the different structure. It's the same. Technically, it's the same. So what if I have this structure? See this?
Yeah. Here the longest chain would be 1, 2, 3, 4, 5. Methyl pentane as well. But this would be 2 methyl pentane.
This yes.
Yeah.
Like where is the structure? Yeah, this one and this one. Technically, they are the same. Technically, they are the same. Okay.
Okay. Yeah.
Okay. So then carbon, 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 then carbon, then carbon.
Okay.
Yes.
This one.
Mhm.
Um, 1, 2, 3, 4. Four. So four carbon means butane something. Yeah, butane. This would be two dimethyl. No, dimethyl. No, two methyl dibutane something, or two dimethyl butane, because there are two methyl, so two
So
dimethyl.
one, two, three, four. One, two, three, four. Whether you count from the left hand side, whether you count from the right hand side, they are getting the same number. I can say that the first branch at the second position, the second branch present at the third position. So we have the two branches. I have mentioned the position of each and every branch, that is going to be 2 comma 3. So this would be di, then methyl, and then butane. 2 comma
Right.
3 dimethyl and butane. What if I draw the structure like that? Let's say I'm doing like that.
It's the same thing, right?
Uh, I can select the long chain branch like that. So do you think that the name is going to be the same? I have just copied it. They are the same. 6 carbon atoms.
Yeah, it would be the same because they both are still on the second carbon.
One, two, three, four. So
And
it
one, two,
means
three, four.
that the name should be the same.
It will be two, three, right? Right, two, three. Sorry. Okay.
Okay. And then what about this one?
Um. Okay. This one's wrong. Where is it? No, it's correct. Never mind. Uh, just like 2-dimethyl butane. No, yeah.
2-dimethyl.
Uh, yeah. I think I'm not sure. Like, I don't get it because the longest carbon chain would
Long
still
chain?
be like the middle one. Yeah.
Yep. So one, two, three, four, rather than one, two, three, four.
Hmm.
On the right hand side, it would be getting the third. Yeah. So 2 comma 2 dimethyl and pentane. 2
Two,
comma
two
2,
or two.
like 2 comma 2, because at the same position, at the second position, at the same position, the branches
No, no.
are.
When you have numbered it, you're getting it at 3. You're not getting it at 2.
No, I was saying when you will be counting this from the right hand side, it would be getting the third number. According to the rule, the branch should get the least number, isn't it? So the right
Yeah.
one numbering is wrong. So we have to give the number from the left hand side, because from the left hand side they are having the second position. So I would consider the second position. So at the second position, the two methyl groups are attached. So whether they are the same or different, so you have to write down the position twice. Like some people say why it should not be 2-dimethyl. Makes sense. Like at the second position, dimethyl, like we have two methyl groups, the same thing. But we have to give the name in a proper way. Sometime might be possible the you would have the different branches, like let's say one branch is methyl and another branch is ethyl. Then in that case, what you will do, of course, then you have to clarify individually that this is going to be 2-methyl and this is going to be 2-ethyl. So that's why, to make it very clear, if the two branches are present at the same position, so you have to write down the number twice as well. Like that's why I have written 2 twice, 2 comma 2. The first 2 is for the first branch and the second 2 is for the second branch. So 2 comma 2, like the number of the branch is mentioned twice. So 2 comma 2 and then again dimethyl. 2 comma 2 then again dimethyl. So 2 2 dimethyl and then butane.
Okay.
Okay. Or then I can say, and we have to do up to 6 carbon atoms, right? It's mandatory. Up
Hmm.
to 6 carbon atoms we have to do. Okay. And then what if I have this compound? Uh, one, two, three, four, and then five. Of course, hydrogens are written like that. Then what you will do?
Um, it's on the second carbon, right? So, sir, I also didn't get the why did you write the 2,2 dimethyl thing? Can you explain that again?
Yeah. Uh, you can see the branch is present at the second position, right?
Hmm.
So on the second position, I have two branches. So two
Yeah.
branches means that this branch and this branch. So this two is for this one and this two is for this one. That's why I have written two twice because I have two branches.
And then before, why did you write 2,3 then?
Like this one
Yeah, yeah, 2,3 dimethyl butane.
because one branch is present at the second position,
Hmm.
another branch is present at the third position. So they are they are on the different carbon.
Okay, okay, got it. So you
And
only take in the account, like you only take one numbering in account. Like either I can say, like you have written 1, 2, 3, 4, and then under that you have also written 1, 2, 3, 4. That's
yeah,
why I got confused.
yeah, exactly.
But okay, it makes sense now. I
Okay.
get it.
So means this is
Okay.
the
This one will be
longest or this is the longest
both. Both can be. Both are right. Uh,
because both has
yeah.
three carbon atoms,
We
right?
can
Okay.
say this is 2,2 dimethyl methane. 2,2 dimethyl
One, two,
pentane.
three. Three carbon atoms means propane.
Yeah. Oh, sorry. Yeah, propane. Right.
2,2 dimethyl and then propane.
Propane.
And what if you have this structure?
Um. Okay.
Yeah.
Okay. So this will be um 2,3 dimethyl butane.
Nice. Like
Yeah.
you took the long chain like that.
No.
And these are the two branches, isn't it?
I took it in like a different way, but yeah.
One, two, three, four.
Hmm.
So first branch is present at the second position. Second branch is present at the third position. The name of the branch is methyl, not ethyl. And on the long chain, I have four carbon atoms. It's gonna be butane. So it's 2, comma 3 dimethyl butane. Okay.
Okay.
Let's say if I have this one. So remember when I have one branch in a ring, when I have one branch in a ring, so it's supposed to be one. It should have the least number. Like the
Hmm.
position of the branch would be counted from one. So in the long chain, like of course this is not a long chain, like in the ring, how many carbon atoms you have? Four carbon atoms. So you will say cyclobutane,
Okay.
cyclobutane. But this is going to be methyl cyclobutane. This is going to be methyl cyclobutane. or 1 methyl cyclobutane. I'm not saying that this is going to be 1 because this is understood. If there is only one branch, so the branch would be at the first position. So I would say this is going to be 1. So methyl cyclobutane. And cyclobutane is something else. I'm talking about the ring. And if there is written only methyl, again, it's understood that this would be the branch. What if I would write this ring in this manner, like that?
It's the same thing, yeah. Oh, okay, never mind.
Then what you would say?
Dimethyl cyclobutane.
Now you have to give the position. Yeah, like you have to name
Oh,
the
okay.
number the
You
position
can
basically.
say two, three, no wait, two, four
The
dimethyl cyclobutane.
the branch should get the least number, right? Or you will start the like from where you are starting the numbering from where? From this carbon atom?
Yeah, you can say anywhere like
Not
that way.
anywhere, because branch is preferred. Branch is preferred.
Okay.
Whether you can count from this one, two, three, four, and whether you can count from this one, two, three, and then four. In
Why
both
don't you like
cases,
do it like so that you start from like H2C instead of HC?
when you will be starting from H2C, so the branch would be having the second number. Second
Yeah.
number is largest as compared to the first.
So you
So
should
that's
have
why
like
I'm starting the position from the CH3 so that it can get the least number, that is 1.
all right, okay.
So what should be the name for this?
1,3
1
dimethyl
comma
cyclobutane
3, 1 comma 3 dimethyl
cyclobutane.
cyclobutane. Yes, then what would you say for this?
Um, this is 1,2 dimethyl cyclobutane.
1,
Two.
good. Cyclobutane. 1, then 2, then 3, then 4. What if I would be doing like that? 1, 2, then 3, then 4. What's wrong with that?
It's not the smallest number.
Exactly. So both branches, this is the priority that the both branches should get the least number if this is possible. And if not possible, so then you can give the name as much like the branch should get the least number. As much as possible, you are supposed to try this if they are getting the same number or not. So 1 comma 2 dimethyl and cyclobutane. Or what about this?
Um, this is not cyclo. This has to be something else, no?
This is cyclo, but
Oh,
it's a
okay.
ring of 5
Yeah.
sides. It's a
Oh, so
pentagon.
it's the pentane.
So
So
methyl
Yeah, just methylpentane. Methyl cyclopentane.
Cyclopentane, yes. Yes. What about this one?
Uh, this one is 1, 2, 3, 4, 5. Wait 1 second. Um, 1, 2, 3. No, 1, 2, 4. Try methyl cyclopentane or something.
Cyclopentane, yes.
No, no. Why don't you say 1, 2, 4 instead of 1, 3, 4?
1, 2, 4.
Yeah, like you start from the branches down, right? So say 1, 2, 3, and then 4. So 1, 2, 4.
At the second position. Oh, yeah, yeah, yeah. Got it. What you are saying. So means that I should number it like that. Let
Yep,
me change the color like that, right?
yep.
So 1, 2, 4.
Yep.
Trimethyl
Try pen cyclopentane. Yeah.
and cyclopentane. Trimethyl cyclopentane. So this is
Yep.
all about the ring naming, like whenever the ring is given, so how can I name it? So then you have to again select a branch. Where is the branch? And then you have to just number it. It should
Mm.
get the least number. And then you have to write down the name.
Right
So the
here. That.
branch starts from, so the ring starts from 3 carbon atoms, like propane, cyclopropane. And also you can notice um, the general formula for alkane and the general formula for the general formula for alkene and the general formula for cycloalkane, they are the same. If you have noticed it. Let's say if I say what's the formula for butene, you will say C4H8. You will say C4H8. This is butene. But means 4 and ene means double bond. So the formula is C4H8. Why? Because the general formula for alkene is CnH2n. This is the general formula for alkene. So if this is the general formula for alkene, if you can count cyclobutane having the single covalent bond, in cyclobutane having the single covalent bond, you will see that the number of atoms are same. Like C4H8, C4H8, they would be the same. C4H8, C4H8. And that's it. C4H8, C4H8.
Okay. All right.
So I'm saying because no, it's not 100 always true that whenever I have double hydrogen as compared to carbon, so it must have a double covalent bond. No, might be possible that's going to be the ring structure. Might be possible there should be a ring structure. Okay.
Yeah, yeah, okay.
Yeah. Or okay. What is this?
What is this one? This would be one, two, three, four, five, six. Uh, this would be methyl hexane. Methyl cyclohexane. Cyclohexane.
Methyl cyclohexane. Okay, that's the IUPAC nomenclature of alkane. In the same way, we have to discuss for alkene, and then we have to discuss for alcohol, then we have to discuss for halogenoalkane. So,
Right.
like one by one, we have to discuss the IUPAC naming and with suffixes. Because in this we have a single covalent bond. So what I have written ANE, ANE. In each and every name, I did ANE, N. For alkene, we would be doing
Yeah.
ene. For alcohol, all the same thing. Okay.